Welcome to this how-to video from CrysAlisᴾṕ. I'm your host Lee Daniels, and today we're considering the source of that one bad reflection in your integrated dataset. Here is a structure with a reflection intensity problem. This is a well-known structure. You may recognize it. Let's take a look at the statistics up at the top right of the OLX2 display. We have a good data set integrated to a reasonably high resolution. The refinement has converged. I over sigma I is good. Our int is good at about 2.77%, and there are no large positive or negative peaks in the difference map. But the R value seems high for data of this quality, and the value of the goodness of fit is outside the acceptable limits for a high quality structure. Once we're to this point in the refinement, I usually look at this info tab and then go down to this section that says bad reflections. So let's open that up and look more closely at this list. These are the worst fitting reflections in our model. The top one is a huge outlier and it's flagged red. This number is related to the difference in fcalc and fobs and is negative when fobs is the larger number. Also, because we're using ShellX, we can look at the ShellX list file. We go down to the section labeled Most Disagreeable Reflections, and we see that the actual value of fobs is 162,000 and fcalc is 7. So yes, it's a very large discrepancy for the 3-10-1 reflection. So why do we have this one really bad reflection? So we go back to CrysAlisᴾṕ and open up the experiment. Look down at this button that says HKL, which allows us to find a reflection in the frame data. We're looking for the 3-10-1 reflection. It's orthorhombic, so we need to tell it to find the symmetry equivalent ones. I see that there's one occurrence. It shows the indices 3-10-1, the x and y coordinates, and it tells us the run number and the frame number. If I click on that, the display goes directly to that frame. And if you look down here, you'll see that CrysAlisᴾপ্ৰভ puts a cross where that reflection is. Let's zoom in on the part of the image where CrysAlisᴾপ্ৰভ put the marker. And near the marker, we see a couple of pixels that are a lighter color. I turn on the information button and hover around that area and note that most of the pixels have 0 counts or 1 count. When I get to the white pixels, I see that one has a value of about 20,000 and the other about 160,000 counts. So we have a couple of hot pixels on the detector. So I need to mask those pixels so they're ignored by CrysAlisᴾপ্ৰভ. You can search for the string hot pixels in the CrysAlisᴾপ্ৰভ help file for more information about how to do that, or contact your CrysAlisᴾṕ service department. I've now masked those pixels in this data set, and I went back and reintegrated the data. So let's go back and look at the structure. I've copied the new HKL file into this structure folder, and I can select it here with the HKL dropdown. Now I refine the structure with the updated HKL file for a few cycles of refinement. The R value settles down to just below 3%, and the goodness of fit moves right into the range where it should be for an excellent data set and structure. I hope that this description of the find reflection function in CrysAlisᴾপ্ৰভ was helpful. As always, reach out to us if you have any questions.